Okay, this is part 2 of the practice test for the first test in Computer Programming 202. And we got the runner across the screen, but we also need to have him turn around. Let me see. When he gets to the other side of the screen, he's supposed to turn around. I think I'm looking at the problem description here. Okay, so he's going to run back and forth forever. So we need to be able to detect two things. And also, I just read the instructions again, and this is supposed to be, we'll just call this runner speed. And we'll set that equal to 1 up here. And if we ever need to change it, we can just go up here and do that. And now what we need to do is when we update his position, which is something we're doing right here, we need to check and see if he hits one of the walls. Okay, so if, let me see, the runner position, now runner's position is a vector, so it's going to be a float. So if the x position plus the rectangle, let me see, hang on a second, what else do we have? Okay, I want him to turn around when, now this is just for the source, so there's no scaling going on there. So what I'm going to have to do is the width, okay, the runner position dot x will be the upper left hand corner. And so when he gets to within the width of a frame of hitting the right edge, then he should turn around. So I want to add on the runner dot source dot width times the scale. Okay, so that'll give me the actual number of pixels, and if that is greater than my playing area dot right, then I want to turn the guy around. Okay, and turning the guy around involves two things. I want to take his sprite effects, so runner dot sprite effect equals sprite effects dot, and let me see, I always get these confused, which one is horizontal, which one is vertical. I think it's vertical. We'll try that. So hopefully that will turn them around. It'll either turn them around or turn them upside down. If it turns them upside down, then we know we have to change it back to horizontal. And then I want, so I turn them around, and then I need to change my speed. So runner speed equals minus runner speed, and I'll just turn them around. Okay, so what did I do wrong here? Yeah, flip vertically. I don't know why I typed in vertical. Okay, now, so that should get him to turn around when he hits the right edge. Let's see what happens. Okay, now when he bumps into the wall on the other side here, let's see what happens. Okay, I had a 50-50 chance here, and I picked the wrong one. So I want to flip him horizontally. Okay, so it looks like that's working. And then the other thing I want to do is I want to check on the other side. If runner dot position dot x And this time I need to worry about scale because the x coordinate is the left edge. No matter what he scaled to, it'll still be his left edge. If that is less than or equal to playing area dot left, then I want to do the same thing. And actually, it's the exact same two instructions. If I flip him horizontally again, he'll go back the other way. And if his speed is currently negative and I take the opposite of that, it'll be a positive and he'll go back to the right again. So let's try this. Actually, let's stop this a second. Let's make it go faster. Let's make this guy sprint across the screen here. So I'm going to change this to a 3, so it'll go 3 times as fast as it did before. Okay, he should turn around here. Ooh, he did not turn around. What did I do wrong? Okay, this is a little tricky. What I'm thinking is happening is that I may be turning him around twice here. If you remember earlier in the term when we would have the ball stick to the paddle, I think that's the same kind of problem we're having here. And so what I'm going to do is I'm going to make sure that when he gets to one end, then I make sure if he's gone off the end a little bit, I'm going to make sure I move him back far enough so that none of the runner is off either edge of the screen. So I'm going to change the runner dot position dot x is going to be set equal to, and this time it's going to be the playing area dot right minus the runner dot source dot width times scale. Okay, and that's a vector, so it doesn't matter that I've got floats over here on the right side. Now, if he's over on the left side and he hits the edge, then runner dot position dot x should just be set equal to the playing area dot left. Okay, so let's try that out and see if that fixes our problem. Well, this is interesting because he is clearly reversing directions, but he's not getting flipped. And both of those instructions are in the same place, and he's not getting flipped. I don't think he's getting flipped twice. I suppose there would be a little bit of a flicker. And actually back on this end, he should flip horizontally again too. Okay, I just realized what I was doing wrong. I had forgotten how flip horizontally works. It doesn't continually flip him back and forth. Flipping horizontally just turns him around from his normal orientation, and his normal orientation is to the right. So this says make him go to the left. What I have to do here is I have to set it back to none. So it will just draw him on the screen the way that he exists in the file. So that's what my problem was. Let's try it now. I'm 99% sure this is going to work. Okay, hit the wall, turn around. Hit the wall, turn around. And he's going to do that forever. And we can try and shrink him down a little bit with the Y button, I think. Okay, and now he's not shrinking. So we have another problem we need to fix. That's too bad because that was working before. So, let me see. Where was I doing my scale here? If I press the X button, scale should be 1.02. Oh, and I redid this. No, that's scale. I'm modifying scale. So I should be increasing the scale, and here I should be decreasing the scale. And again, we had an operator error here. I was just holding the button down, which meant it was only getting increased or decreased one time, and a 2% increase we're not even going to notice. So I needed to be pushing the button repeatedly. That's why I have the previous one in there. So if I bounce on the X, he gets bigger and bigger and bigger and bigger, and if I bounce on the Y here, he gets smaller and smaller and smaller and smaller until eventually he should get down to 50% height, and then he doesn't get any smaller than that. I'm pushing on the Y, I'm pushing on the Y, and that must be 50%. It actually looks smaller than 50% to me, but you got to remember we're doing 50% in both directions, so he's actually going to be like 1/4 of his original area, even if it's half the height. So I think we've got that working now. Okay, now what else do we want to do? Use the gamepad to do the following. Write a void method called reverse direction. And so where's my code to reverse direction here? My code to reverse direction here is these instructions right here. So we're going to reverse directions on looking at two other buttons here. So if pad.buttons.b, whoops, yeah, .b, if it's currently pressed and previously it was released, then what I want to do is I want to call reverse direction. And it's a void method. It doesn't say anything about passing parameters, I don't think. So reverse direction is simply going to do one thing. So void and so reversing direction simply turns the runner speed around. Okay, and that's all there is to that. It's a short method, but that's okay. Write a void method called speed up. When the user presses the left thumbstick up, immediately increase the speed of the runner by 1 pixel per tick. Only do this once for each time the user presses the thumbstick in the up direction. That is only make the change when the previous state of the left thumbstick's Y value is 0 and the current state is positive. Okay, so I want void speed up. And speeding up is going to add 1. So runner speed. Let me see. Well, if I want to speed him in both directions, then I'm going to have to do something like this. If runner speed is positive, then runner speed plus plus. Else, if, I don't need an if it's not positive, we're going to assume it's negative. Runner speed minus minus. Okay. And yeah, so if he's currently positive 3, then it'll go to a positive 4. If it's currently a negative 3, it'll go to a negative 4. So that should work. We've got to figure out when to call that. Down here, we're going to call that on the Y thumbstick, so or the Y part of the left thumbstick. So pad dot thumbsticks dot left dot Y. If it's greater than 0 on this tick and Now I need a previous pad, which I did not put up there. So previous, oh, I did put that up there. If previous pad is dot thumbsticks dot left dot y was equal to 0, then they just pushed it. And so I want to call speed up. Okay, and then it looks like we're going to do one called slow down. Okay, and it looks like that's the exact opposite, just going in the other direction. Do not let the value of the speed drop below 0. Slow down. Okay, so I guess we can bring him to a dead stop. So void slow down, and if runner speed is greater than 1, then it's a positive number, and we'll do runner speed minus minus. Okay, and else, now we do need an if, because we got to check to make sure if runner speed is less than a -1, then we want to slow him down. You slow down a negative number by adding 1 to it. Okay, but if his speed is equal to 1 up here and I subtract 1, then I'm down to 0, and I brought him to a stop, and it said not to do that. Down here, if it's equal to -1 and I add 1, it's going to go to 0, and it said not to do that. So I need to protect those two instructions. Now, when do I call slow down? I call slow down if pad.thumbsticks.left.y is less than 0 on this tick, and it was 0 on the last tick, then slow down. Okay, and let's give that a try now. So it's going to be A and B. Okay, and whoa. I'm pressing B there, and he's going backwards. I'm pressing A, and nothing seems to be happening. Let's see what happens if he turns around and I press A. Okay, so we got a problem here. Okay, no, the problem is I wasn't using the thumbstick, so I was doing A and B, and B is the only one that works now. Let's try it with the left thumbstick, and I'm going to push the left thumbstick up. Should make him go faster. I got to do it. Now I'm going to slow him down. I've slowed him down as far as he will go. I'm going to speed him up. Every time I push the button, I push it about 4 times there, and pretty soon he's just going to be bouncing back and forth. Okay, so that appears to be working as long as I push the right buttons on the gamepad. And the last thing here is to do an array. So I want an array of sprite structs called fighters. So let's go up here if we want an array. Let's go up here and do it with the other one. So sprite struct fighter, and it's an array. So I got to put the pair of square brackets right here. Okay, so that makes it into an array. And in the initialize method, I want to set the memory for 5 elements in my array. That's simply doing this. Fighter equals new sprite struct 5. And that'll give me 5 numbers, 5 items numbered from 0 to 4. Now in the load content, I want to load the fighter picture in for all 5. So we should do that with a loop for int I equals 0, I is less than 5, semicolon I plus plus. And I want fighter, and I want the current one, I, fighter sub I, dot texture equals content dot load texture 2D, and the texture is right over here, fighter. So, okay, so that'll put a copy in each one, and then I want to initialize the vector position for each one, and I'm thinking I can probably put this all in a loop here, so in one loop. So I want to initialize the position vector. So fighter, and it's an array, so I've got to always do the name followed by a subscript. And what I want is the position dot x. It's going to go across the top of the screen at 100 pixel intervals. So I want 0, 100, 200, 300, 400, and that just happens to be I times 100. So that should get the x position for me. For the source rectangle, use null. Okay, I'm not sure I can do this in here. I'm going to give it a try though. And it appears that, no, it appears that I cannot. It's a non-nullable value. Okay. Then in the call is where we're going to have to do that. That's what I thought. Set the color for each to white. So fighter dot color equals colors, color dot white, and sprite effect to none. And it says must sprite use a loop, which we did. And then the draw method, draw all 5 of those pictures. So I don't need this blank line here, so let's clean that up. And then down here in my draw method, I need a for loop to draw the 4 fighters. For, and this is my algorithm for doing loops. I is less than 5, and normally you'd do a constant for that, a named constant, but I won't make you do that on a test because time is important on a test. So what I want to do is I want to draw each one. So sprite batch dot draw and fighter sub I dot texture, fighter sub I dot position, fighter, and then the source is going to be null. Here you can pass null in. And then fighter dot color 0 comma, and then what is this one? The origin. Yeah, that's going to be vector 2, 0 again. I don't really need this. I need the other items. And then scale is going to be 1 on this one. And I'm not sure what happened there, but let's try that again. Scale is going to be 1 comma, and use the sprite effect, and 0. Okay, and I don't know where that underscore came from. Let's delete that underscore. And now let's try to run it, and we should get 5 fighters plastered across the top of the screen at 100 pixel intervals, and there they are. And that's the end of the practice test.